Where have you come inside, Nasa? Hall. Come. Ask me. Special address. Please. Assistant. Come now.
A very good evening and welcome to the workshop on space situational awareness and space traffic management, growing concerns on outer space environment. We are Nisha Nair and Himanshu Pandey, and it is a proud privilege to be serving as your hosts for the day. Uddharet Atmanatmanam Natmanam Avasadayet Atmaiva hi Atmana Bandhuhu Atmaiva Ripuratmanaha.
Meaning, we shall elevate ourselves through the power of our own minds and not let ourselves degrade. For we can be our own friend as well as our own enemies. The above quote from the Bhagavad Gita is very apt representation of today's space situation and the theme of this conference. On behalf of the organizing committee, I would like to extend a warm welcome to all the dignitaries, delegates, speakers, and the sponsors. We are delighted to have you here with us today, and we are committed to providing a valuable and memorable experience to each one of you.
We are honored to have here with us today eminent personalities whose expertise and experience will undoubtedly enrich the discussions and interactions that will be held throughout the program.
Before we move ahead, let us invite the dignitaries onto the dais. May I request Sri S. Somnath, Dr. G. Satish Reddy, Dr. Pavan Kumar Goenka, Sri M. Shankaran, Dr. D. Radhakrishnan, and Sri B. N. Ramakrishna to kindly occupy their seat. I request Dr. A. K. Anil Kumar and Dr. Vinod Kumar to kindly escort the dignitaries to the dais.
As all of us know, the space around our planet is a complex and fragile ecosystem that is vital to our daily lives. From the satellites that power our communication networks to the space debris that threaten the safety of our satellites and our astronauts, the space environment has become an increasingly important area of concern for scientists around the globe. By working together and addressing these issues with a sense of urgency and responsibility, we together can ensure the long term health and sustainability of the space environment for all of us. I would like to thank all of you for being here. Your presence here this evening is a testament to the commitment towards addressing the growing concerns on space environment, and we are grateful to be a part of this community. Without further ado, let's get started.
An invocation is a call to something greater than ourselves, a call to be guided by a power beyond our own understanding, and to be filled with a spirit of love and compassion. I now welcome onto the dais Sri Raghavendra Rao to render the invocation.
I am M. Raghavendra Rao, working in ISTRAC, Bengaluru. Now I am performing Sri Ganesha Pancharatta Stotram, written by Jagadguru Sri Adi Shankaracharya. मुदाकरात्तमोदकं सदा विमुक्तिसाधकं कलाधरावतंसकं विलासिलोकरञ्जकम् अनायकैकनायकं विनाशिते भद्यैत्यकं नता शुभाशुनाशकं नमामि तं विनायकम् न तेतरातिभीकरं न ओदितार्कभास्वरं न मत्सुरारिनिर्जरं न दाधिकापदद्धरम् सुरेश्वरं निधीश्वरं गजेश्वरं गणेश्वरं महेश्वरं तमाश्रये परात्परं निरन्तरम् समस्तलोकशङ्करं निरस्तदैत्यकुञ्जरं दरेतरोदरं वरं वरे भवत्रमक्षरम् कृपाकरं क्षमाकरं मुदाकरं यशस्करं मनस्करं नमस्कृतां नमस्करोमि भास्वरम् अकिञ्चनार्तिमार्जनं चिरं तनोक्तिभाजनं पुरारिपूर्वनन्दनं सुरारिगर्वचर्वणम् प्रपञ्चनाशभीषणं धनञ्जयादिभूषणं कपोलदानवारणं भजे पुराणवारणम् नितान्तकान्तदन्तकान्तिमन्तकान्तकात्मजम् अचिन्त्यरूपमन्तराय कृन्तनम् हृदन्तरे निरन्तरं वसन्तमेव योगिनां तमेकदन्तमेव तं विचिन्तयामि सन्ततम् महागणेश पञ्चरत्नमादरेण योऽन्वहं प्रगायति प्रभातके हृदि स्मरन् गणेश्वरम् अरोगतामदोषतां सुसाहितीं सुपुत्रतां समाहितायुरष्टभूति मभ्युपैति सोचिरात् इति शङ्कर श्रीभगवतः कृतौ श्रीगणेशपञ्चरत्नस्तोत्रं समर्पणम् धन्यवाद.
Thank you, sir. That was a beautiful rendition. We are grateful to have had this opportunity to come together in a moment of spiritual reflection and to ask for guidance and blessings as we start the event.
I now request dignitaries on the dais to light the lamp. I request Ms. Akansha, Ms. Srijan to assist. Yeah. The lamp represents the light that guides us on our journey through the life and helps us to see the path ahead. It reminds us to seek knowledge, to seek the truth, and to always strive to be better. So let us take a moment to reflect on the significance of this lamp and to reaffirm our commitment to the learning and the growth.
Thank you, sirs. May this light serve as a beacon, guiding us towards a brighter future. Dr. A.K. Anil Kumar, Associate Director, ISTRAC, Chief General Manager for Safe and Sustainable Space Operations Management, Project Director, Netra, and Chairman Organizing Committee, has been an integral part of this event from the very beginning and has worked tirelessly to ensure that everything runs seamlessly and successfully. Dr. Anil Kumar has brought a wealth of expertise and experience to the table and has played a crucial role in the planning and execution of every aspect of this event. May I now invite Dr. A.K. Anil Kumar to formally welcome this August gathering.
Good evening to all. Respected Secretary DOIS and Chairman ISRO, Somanath sir. Respected Scientific Advisor to Raksha Mandri and former Chairman DRDO, Dr. Satish Reddy. Our Chairman in Space, Dr. Pavan Kumar Goyanga. Sri M. Shankaran, our Advisory Committee Chairman. Sri D. Radhakrishnan, CMD NSIL. Dr. B. N. Ramakrishna, Director ISTRAC, Dr. Vinod Kumar, Executive Secretary, ASI, and all dignitaries of the dais, delegates. In fact, this workshop we planned about 10 months back. It took 10 months to realize this workshop. And to this gathering, I need not tell about the concerns of space debris and the concerns on space situational awareness and space traffic management. Anyway, we are going to discuss thoroughly on all of the aspects, including policy, law, modeling, collision threats, everything we are going to discuss in next 2 days, today as well as tomorrow, as well as day after tomorrow. And also we brought for this workshop, in fact, the backbone of space situational awareness is the observational facilities and observations. So we thought the importance of that has to be brought out by this workshop. So we have put apart one full day for industry meet who are the leading industries in this arena. Now, I am not going to talk much about SSA and STM. I know we have a keynote speaker, keynote speech is there, then later we have an opening plenary, and tomorrow 12 United talks are there. So everybody will be speaking about that. And I will just go to my duty as on today, welcoming our guests. First of all, this when we thought of doing such a workshop on SSA and STM, I made a draft proposal and sent to Chairman ISRO, and he has written on that. Excellent proposal. Please go ahead. And he has written one condition: it should be an international meet. International speakers should be there. With that, everything started. And immediately we have sent a communication to many international speakers, experts in this domain, to find out whether we will get many international speakers to do such a worthy workshop. I have sent about 12 people, and astonishingly, I got reply within 2-3 days. All of them are accepting invitation, and only thing is 2-3 people said the timing is not good for me. Otherwise, I would have come. It's actually really a wonder, and I am thankful to all the speakers who has immediately accepted this to attend to this workshop, to give the invited speeches. Now, Chairman ISRO, from that time onwards, Secretary DOS and Chairman ISRO, he was motivating us. He was actually, in fact, 2 times he has taken review of this workshop. What are the arrangements, everything. And he has visited this hotel beforehand. And I will be very much thankful. I am placing on record our record of appreciation. Also, I am welcoming him for this workshop. Thank you, sir.
Yeah.
Yeah, when we thought about a keynote speaker, I was discussing with the chairman ISRO about the keynote speaker. First name came to our mind was former Secretary Defense and R&D and Chairman DRDO, presently scientific advisor to Raksha Mandri, Dr. G. Satish Reddy's name only came into our mind. Immediately, Chairman just contacted. He has readily agreed. And in fact, I got a little tension up to last Saturday. He was very busy, man. And thank you, sir, for finding out the time for this conference, this workshop, to give the keynote speech. I am welcoming Sri Satish Reddy for this, Dr. Satish Reddy for this. As all of you know, Chairman InSpace, Dr. Pavankumar Goenka, he is leading the new space reforms in India, bringing all non-government entities into the fold of space. And we beforehand itself, we discussed with him, and the industry meet is arranged. And today already he had discussions with many industries, and he'll be continuing discussions today after this inauguration also. I am welcoming Dr. Pavankumar Goenka for this. So one of the person giving full support and giving all the advices and suggestions, making this workshop in this manner, it is none other than Director URC, Sri M. Shankaran. He has been supporting us all the way as a Chairman Advisory Committee, giving us all the suggestions and guidance. I would like to welcome you, sir, for this workshop. This workshop is being organized by ISRO and Astronautical Society of India together in association with InSpace and NSIL. NSIL is the commercial wing of Department of Space, and CMD of NSIL is D. Radhakrishnan. He has supported us in organizing this seminar in workshop in a good manner. I would like to welcome D. Radhakrishnan to this. As you know, this workshop is organized by ISRO, but the main nodal agency is ISTRAC. So, ISTRAC director has been giving, including fund, a lot of things, support, everything. And he was overseeing all the arrangements, all the organizational things he was overseeing. I would like to welcome Sri B.N. Ramakrishna for this workshop. When the advisory committee suggested to organize this seminar with in association with Astronautical Society of India, that day onwards, for all of the organizing things and to handle total funds and expenditure, everything, and making the program, tentative program, now finalize the program, everything ready, and in fact, handling the last 3 days, all the programs, Dr. Vinod Kumar was with me. I would like to welcome you, sir, Dr. Vinod Kumar. Today, after this inaugural function, we have an opening plenary, and opening plenary speaker is Dr. Jesse Lu. He is the chief scientist in NASA on space debris. I would like to welcome you, sir. We have with us a galaxy of guests here, and we have Sri A.S. Kiran Kumar, sir, Space Commission member, former secretary and secretary DOS and chairman ISRO. I would like to welcome you, sir, for this function. We have with us our former secretary DOS, and former chairman ISRO, K. Sivan, sir. I would like to welcome you, sir, for this. Now we have with us Dr. B.N. Suresh, sir, P.S. Goyal, sir, Dr. V. Adimurthy, sir, who are all giving us a lot of support and motivation for doing this workshop. In fact, Dr. Adimurthy, together with A.S. Ganeshan, Dr. R.K. Sharma, Priyankar Bandyopadhyaya, they have started the activities in India on space debris related studies. I would welcome all of you, sir. We have with us AVM DV Code. He is the Director General of DSA. We have Rear Admiral Dr. Suresh from NTRO and Dr. Ram Mohan from NSCS. I would like to welcome all of you, sir. Also from Indian Space Association, we have Dr. A.K. Bhatt. I would like to welcome. We have a lot of invited speakers who are experts in this field. Dr. Tim Florer, Dr. Shinichi Nakamura from JAXA, Dr. Tim Florer from ESA, Dr. Christoph Bonal from CNES, from Dr. Professor Thomas Shinnet, Dr. Juan Carlos, Dr. Brian Whedon, Dr. R. Uma Maheshwaran, Dr. Anjana Kaul, Dr. Ajit Patia, Dr. Scott D. Barder, and Dr. Hrithik Neelagandan. I would like to welcome all these invited speakers to this workshop. We have almost all center directors of ISRO and DRDO. I would like to welcome all of you, sir, for this workshop. We have directors of program office of ISRO headquarters, director of IAEA, and director of ARIS. And we have directors and officers from Department of Space, InSpace, and ENSIL. Associate directors and deputy directors of various centers. We have our industry partners. They are the sponsors. There are 13 sponsors from industries. I would like to welcome all of you, sir, to this workshop. There are a lot of faculties and students from various research institutes. In fact, we have restricted the number of students because there was a lot of students interested in this workshop, but we restricted to about 30 to 40 because of the capacity of the hall was less. We will be making another session for all the students. So I would like to welcome all the faculties and students to this workshop. And I would like to welcome delegates from all over India, visual media and print media who has come here, and also all of my organizing committee members. Let me wish a wonderful, scintillating coming 2 days with lots of knowledge and motivation. Thank you, sir. Jai Hind.
Yeah, thank you, sir. We would like to welcome Dr. Anil Kumar with a bouquet. I request Sri Balamurgan to do the honors. Sri M. Sankaran is a distinguished scientist and the director of UR Rao Space Center of ISRO. He is currently leading the satellite fraternity in realizing various types of satellites to meet the national requirements in the areas of communication, navigation, remote sensing, meteorology, and interplanetary exploration. As a chairman of advisory committee, he has been a constant support to the organizing committee in all its endeavors. I would like to invite Sri M. Shankaran, chairman of advisory committee, to introduce the theme.
Thank you. Good afternoon, ladies and gentlemen. Distinguished delegates on and off the dais. It's my pleasure to be here to introduce the theme for this 3-day workshop to all of you. Though it's a kind of redundant job, all of you are experts in this area, or at least students of this subject. Still, I take this opportunity to bring out the thought process behind organizing this workshop as a way forward towards sustainable use of the outer space. As most of the people who are associated with spacecraft and launch vehicle activities are aware, we do have a situation at our hand. The dictionary definition of situational awareness tells three attributes to situational awareness. That is, first one is to collect the information about the situation. Second one is to understand the situation through the data that is available. The third point is to anticipate what is going to come in future. So all these three, when they happen together, we can call it as we have situational awareness. So as I mentioned, all of us who work in this domain, we all are aware that there is a situation we have.
Because when the first satellite Sputnik was launched, it captured the imagination of several people, not immediately, but over a period of time. And this growth in this interest in this area has become now exponential. Maybe it is becoming harmonic progression also nowadays, because every week or every alternate day we are seeing news of somebody launching something into space. Uh, though as space professionals, we are all happy that the domain in which we are working is turning out to be very useful to the society, and even business feels it is a place uh, to be, and want a piece of the action. Everybody wants a piece of the action. But as people who are also involved in the safety of the satellites that are launched, and also even to find a slot for launching a satellite at a given time, because some of the missions have a very, very tight launch window, 5 minutes, or even there are missions where you want to restrict the launch window to 1 or 2 minutes. And my friend Anil Kumar will come and tell, no, 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 you cannot launch at that instant. There is one X satellite is passing the trajectory of the vehicle, you need to delay it by 2 seconds. This in fact happened last our last launch. I think 3 times we had to move our lift-off time, just to ensure that we are not crossing the path of another orbiting object in space. So we do have a situation in our hands. And what is the solution for this? It is not just only sufficient that we are aware that we have a situation, we also need to manage the situation. The situational management, the definition of the management books tells there are four ways, 4 steps is what is told: telling, selling, participation, and delegation. So it appears that delegation is not going to work in this domain. So we need to look at the other three, that is telling, selling, and participation. Telling is what that we do have a problem. This needs to be told to everybody who are already in the business, and those who are thinking that they want to get into this business and launch objects into space. We do have to tell. And we also need to sell the idea that we need to do something about it. It is not going to be business as usual. You cannot simply launch at your will and wish what you want to launch. So we need to sell this idea that there is a need for regulation, and there is a need for restraint and self regulation. Because like most multilateral systems, where every country has its own sovereignty and has their own interest to be guided by, it is only selling this idea that you need to be more responsible is the only solution it appears to be, because there are no really enforceable instruments which can make everybody to follow. So we need to sell the idea that there is a need for awareness and regulation in launching objects into the space. And participation, that it is also essential that in this awareness and management domain, we need to ensure that everybody who has an interest today, or who is likely to have an interest in future in the domain of launching objects into space, need to participate in this activity of situational awareness as well as the space traffic management. So that is what I feel, that the textbook definitions are, as usual, are all correct, and we can always find that there is a need to follow these guidelines. So as a part of ISRO's own SSA and STM efforts, we have been ramping up these things, that the pace in which we are trying to gather the information, which today is mainly based on information that is available through other sources than in India. So we have now we are ramping up our own observational facilities in India towards the space situational awareness, and also we need to understand this problem. What is the magnitude of this problem? So we need to spread this information out, and we want to everybody else to participate in this. That is the reason why we thought that a conference or a workshop will be a good idea. But for a conference to be made, to be organized in this subject, there are not too many people in India who are working in this subject at the forefront, at the cutting edge. There are very few people are working. All around the world also the situation is the same. There are not many people around the world also who are working in this area. So instead of uh, thinking of making a conference where the discussions will get more diluted, it is felt that it is appropriate to get experts in this field who are at the forefront of this space situational awareness and space traffic management to come down to India and speak about this subject. And the timing cannot be more appropriate because last couple of years the government of India has opened up the space sector in India for participation by everyone in this country, and it is essential that we enable this new entrant and very enthusiastic participants to become aware of the problems associated with the SSA and STM. So we felt that we need to make experts come down to India and speak, so that the magnitude of the problem and the gravity of the situation is understood by not only the established players but also potential future players who, like elsewhere in the world, making constellations of tens of thousands of satellites. What is going to be the impact? And this is not to say that we should not have this kind of tens of thousands of satellites. When we make such satellites, we need to also ensure that how these satellites are going to get disposed of, how the launch vehicle parts are going to get disposed of, how under failure conditions we are going to manage the system, and how we can position ourselves in different orbits and different uh, inclinations, so that we don't get in the path of each other. So this requires, because there are certain orbits which are very very attractive and everybody wants to go to that orbit because of the obvious advantages. So there is a need for explaining and making people understand. That is the reason this idea of making a workshop where professionals who are working in this area at the very forefront are brought to India and made to speak about this subject, so that the knowledge and the awareness is spread across the spectrum of people who are either involved or in the process of getting involved in the space activities. Towards this conference, 3-day conference has been 3-day workshop has been organized. As Dr. Anil Kumar mentioned, today we have a plenary talk, and tomorrow we have 9 uh, 12 invited talks, followed by a panel discussion. And tomorrow we have a couple of panel discussions, followed by the industry presentation. Those industries who are in the area of space situational awareness equipments and services, followed by at the end a roundtable on the way forward. So packed agenda has been prepared to ensure that both the awareness and management, all aspects of the awareness and management are covered, so that you get a wholesome input for the people who are interested in safe and sustainable space activities for several generations to come. So that is the purpose of this workshop. and with very, very distinguished speakers going to speak today and tomorrow. The people who are going to listen to all these talks during this 3-day session are in for a treat on this subject. And also this this workshop will create more interest in both uh, non-governmental entity of India who are interested in the space activities, as well as the state uh, government agency of space in India, that is ISRO, also to gain more in-depth knowledge on the subject of SSA and STM, so that we can be even more responsible in the future. Thank you for all of you for coming and joining here for this workshop, and happy listening. Thank you.
Thank you, sir, for the lucid introduction of the theme of this conference. Shri S. Somnath, Honorable Chairman ISRO, is an expert in launch vehicle structural systems, structural dynamics, mechanisms, pyrosystems, and launch vehicle integration. I welcome Chairman ISRO for the inaugural address, please, sir.
Good evening, all of you. Respected Dr. Satish Reddy, Dr. Goenka, Shankaran, Radhakrishnan, Ramakrishna, and also Dr. Vinod, and all the distinguished people who are here, invited members, people from all the important organizations who are into this business, professionals who are working on this domain, students. My welcome, hearty welcome to each one of you for this workshop. We are running slightly late in the our program with the idea of getting to hear Dr. Reddy. I won't speak much. Only thing which I wanted to tell you is to thank all of you, to all the invited speakers for accepting to come to this conference and deliver those important talks which we are all eagerly waiting for. And the second question is, I used to ask Anil, what are we really going to gain by conducting this workshop? Is the first question which I asked. Okay, the answer to me is the following. The real danger of space debris, the need of space situational awareness, and the need of space traffic management is well understood. And of course, the teams in the space sector has been working on this domain for some time. Now, time has come to upgrade ourselves in this domain. In terms of the observational capability that we do not have today, it has to be created in India. The analytical tools that we need to create has to be worked upon in the days to come with more data that is going to come by the creation of this observational capability. Then it's not only for the civilian and other related activities, but it's also taking much importance in various other sectors where space is becoming all the more important in the future definition of safety and security for the nation as well. So it requires major dimension change, shift in its importance in various aspects of this as well. And it is all the more important for a country like India to be aware of this need, convince our decision makers in this sector to invest in this and create the backbone of infrastructure, which is essential for having real capability, and also create the set of manpower, human capital in this domain to have observational capability through radars or through their optical observations to handle complex issues that are there in the domain. Also create policy and also the program analyst in this domain who will be able to advocate what is needed for this sector for us, which is national and international. So there are multiple objectives that need to be achieved while conducting this process. And this is what specifically we would like to achieve through the process of conducting this workshop. And who is who in this domain are all here. I think really happy to have all of you here. I believe that you will look at this workshop with great enthusiasm. And over the next 1 year, 2 years, we will be creating what is needed for this country, a roadmap for this sector in terms of having a strong presence of SSA and STM activity in India in the space sector, with the participation of the national space agencies, other agencies in this sector, as well as the private industries. I also want to compliment for those industries who have come forward to address this issue of creating the infrastructure. There's a lot of technical work required in this domain. In looking at those observational capability platforms, create the engineering solutions in much better manner than that anybody else can offer. Also create the software and analytical tools that are required in this sector also and operate them. And we need to create the real network of capability, network-centric capability, look at it from the safety, security of all the space assets that we have and future going to be created. The need of increasing the spacecraft ecosystem is well understood. I think nobody can reduce them. I think even if you advocate that numbers have to come down to reduce debris, it's never going to happen. And it is only going to increase. The trends are well, very, very clear. But only thing is we need to apply rules and regulations on it. And as already been mentioned by Dr. Shankaran, it's not going to be a one-sided story. It's going to be a very complex problem which requires continuous advocacy of various aspects in many, many fora. Of course, many of you have been doing it. So let us also create that type of people who will be able to do this for our nation and as for the entire benefit of the community, that the space community in all across the globe. And this is the purpose. And I believe this will be served by this workshop. So let us wait and watch for all that you are going to listen in the coming days, tomorrow and day after tomorrow. Thank you so much for all of you being here. Wish you happy conferencing. Thank you.
Thank you, sir, for your inspiring inaugural address. Dr. Pawan Kumar Goenka, Chairman of InSpace, it is our honor to have you with us today. May I request Dr. Goenka to release the souvenir and deliver the special address. I request Sri Balamurgan and Soumitra to assist.
Dr. Satish Reddy, Sri Somnathji, friends on the dais, ladies and gentlemen. Let me start off by making an honest confession. Dr. Anil Kumar asked me to be a patron for this conference about 4 months ago. I readily said yes. But then I asked, can you give me a full form of SSA and STM? Because I had no clue what SSA and STM was. In the last 3-4 months, I've been trying to learn something about it. And now I guess I know enough to make some people think some of the time that I know something about this subject. Let me, there's not much that I can tell this audience about the subject of the workshop. You are all experts. But let me try and make a few points as I understand them. Clearly, with the increased global space activity, and I think every country is looking at space in a much more accelerated manner, number of space objects will increase from what is roughly today about 4,500 active space objects to maybe more than 60,000 by the time 2030 comes around. Pieces of trackable debris, which is about 10 centimeter or more, depending on which data you believe, may go up from about 25,000 today to maybe 100,000 at least by 2030. And therefore, the space traffic may become as bad as Bangalore or Mumbai or New York City. And therefore, what we are doing today for space traffic management or situational awareness may not be enough in 2030, and a lot more has to be done. Now, I kind of look at space debris as global warming. It doesn't matter who is causing it. Everyone pays a price for it. And therefore, it's everyone's responsibility to make sure that we control this before it's too late. Now, like in climate change, one can keep arguing who will pay the price, who will bear the cost, and the temperature keeps going up. I hope that same thing doesn't happen in case of space. And the whole space community, which is a very small community, a very close-knit community, comes together and ensures that we have the right technology in place to take care of this problem. Now, as I said earlier, it doesn't matter who causes it. Everyone pays the price. Now, India, for example, can take a view that we have only 60 satellites alive in space today, which is less than 2% of all the satellites, so why should we bother? But like in climate change, India has taken a very responsible position. Similarly, I would hope that we, as a country, will take a very responsible position when it comes to space traffic management and taking care of the debris problem. The most important thing, as was said earlier, I think by Sankran, is everyone has to have the self-discipline in putting space objects in orbit and adhere to all the international agreements and guidelines that have been put in place by the community itself. Now, I think that IADC or UN have to sort of up the ante of what has to be done to ensure that the problem does not get worse as time goes on. I'm not an expert, but can we talk about possibly a moratorium on anti-satellite test, at least for 10 years? Can we say that the 5-year become the standard for post-mission disposal? Now, US has taken lead in both of these. Can the whole global community come together and say we are going to follow this? And clearly, it's a concern. Everyone knows that and accepts that. But also, it's an opportunity. It's an opportunity for many businesses, and I met some of the industry people today, and there are many more who are here. It's an opportunity for the business because the whole SSA, STM, and debris removal will become a fairly large business for companies around the world. And what has to be done clearly are technologies that don't exist today have to be brought on board. There are companies in India, for example, Digantra is working, trying to set up a telescope in north central India. A company called YADS is doing conjunction analysis software. But then many other companies globally are significantly more advanced, and perhaps our companies in India have to learn from these companies and not necessarily reinvent the wheel. We will have to leverage cutting-edge radars, telescopes, build robust database, develop features that will facilitate efficient tracking. New and efficient propulsion system will also be required because the collision avoidant maneuver that today maybe in about 10, 12, 15 in a year by ISRO will probably become 100, 150, 200. And therefore, we need to be more efficient in that. Debris removal, a lot of technologies currently is being worked upon. We'll have to speed up to see some of these technologies become possible, feasible, like nets, magnetic collectors, solar sails, robotic arms, a lot of work happening around the world on these things. Let's see which one of these kind of hit the table first. So responsible use of space need to evolve guidelines and agreement on various things, GNSS, propulsion, deorbiting plan, SSA subscription, docking plates, re-entry plan, all of these. And I'm sure over the next 2 days, the participants will deliberate and come up with some recommendations. So that's all I'll say about SSA and STM. But let me just take a few minutes to talk about space sector in general in India. And there are some international audience here who may not be fully familiar with what's happening in India. India is certainly at the cusp of unleashing its power in space technology and sort of move up its share of the space economy. Foundation is getting laid. Number of startups has gone up significantly in the last 2 years. ISRO is opening its door fully for companies to benefit from its technology, its infrastructure, its expertise. A lot of investment coming in the sector. Some early outcome already from companies like Dhruva, Skyroot, Digantra, Pixel. A lot of potential in India, undoubtedly, but there's a lot of work that also needs to be done. And I've said this in previous conferences, so I will not repeat in detail, but 6 points that I had talked about, where we as a space community need to focus on, is institutional support and policy that clearly needs to come from the government, financial capability of the private sector, where investors will play a very important role, democratization of technology, where ISRO will play a very big role in taking its technology to the private companies, the ecosystem infrastructure development, which for today is sufficient, but for tomorrow will need a lot more. Global partnerships, and I want to talk about this a little bit because I don't think that India needs to reinvent the wheel. We need to partner with global companies around the world, and many of you are already very interested in doing that and have talked to us already. And we should be looking at these partnerships, and the global players need to come forward and partner and participate in the space economy that's going to be growing very rapidly. And finally, skilling, that obviously we need to focus on, because again, in India, primarily the skill is with ISRO, either people working there or retired. And the private industry, again, has to leverage the skill that's available with ISRO and grow their own skill from bottom up. So ISRO, private sector, government organizations, academia, all have to work together. And in space will try and play a role of binder, not just within India, but also internationally. So friends, I want to conclude by saying that the world is moving very fast. We need to pace up. If we could put all of these ingredients together, the Indian space sector would be invincible. There's a huge opportunity waiting for us, but none of this will happen if we don't dream big. And dreaming big will have no value unless we have an action plan to support the big dreams. So I'm sure that we'll have a very exciting journey in 10 years, for 10 years. But before that, the next 2 days are going to be very important and interesting days to understand more of what is happening, what needs to be done, and how do we pace up what needs to be done. Thank you very much for inviting me here today. And I'm glad to have interacted with some of you. Unfortunately, I won't be here tomorrow and day after because there are some unavoidable meetings in Delhi. But I would be here dinner and hope to talk to you, some of you today. Thank you.
Thank you, sir, for the information-packed talk. We now have the keynote address by Dr. G. Satish Reddy, Scientific Advisor to Raksha Mantri. I request Dr. Bulbul Mukherjee, Scientist G, Deputy General Manager and Member Secretary, to kindly introduce. I request the dignitaries on the dais to kindly occupy their seat in the audience, in the front row. So now we have the introduction of the keynote speaker by Dr. Bulbul Mukherjee.
Good evening, distinguished invitees and delegates, dear colleagues, ladies and gentlemen. Space is now recognized as an operational domain for military applications similar to sea, land, air, and cyberspace. Modern warfare depends heavily on space-based services such as satellite communications, navigation, surveillance, and reconnaissance. The concept of space situational awareness originated from an overarching requirement of the military to be continually aware of the dynamic changes and events in space. For a country like India, SSA is essential for ensuring continuity of unhindered access to space and utilizing it for societal benefit, while also addressing the needs for national security. Now, it is my pleasure and privilege to welcome an internationally renowned defense scientist, Dr. G. Satish Reddy, to our SSA and STM themed workshop. Dr. G. Satish Reddy, scientific advisor to Raksha Mantri, has led the development of a large number of critical defense equipment and technologies through a synergetic approach among academia, defense research and development organization, and industries. As a navigational engineer, he made the country self-sufficient in navigational systems by leading the development of critical avionics and missile systems. He is the main architect behind India's maiden successful test of anti-satellite Mission Shakti. His leadership has led the country to leap forward in several domains, namely aircraft, tanks, airborne warning and control system, radars, sonars, torpedoes, as well as advanced technologies like quantum communications, advanced materials, and lasers, etc. Many prestigious national and international institutions have honored him with awards and honorary degree of doctorate. He is the first Indian in over 100 years to be conferred with the prestigious honorary fellowship and silver medal by the Royal Aeronautical Society, London. He is also the first scientist outside the USA to be honored with the Missile System Award by American Institute of Aeronautics and Astronautics in nearly 4 decades. His other prestigious awards include the National Systems Gold Medal, National Design Award, IEI IEEE USA Award for Engineering Excellence, and the Homi Jahangir Bhabha Gold Medal. Sir, we are truly honored for sparing your valuable time to be with us. We now request you to deliver the keynote address. Thank you.
Thank you, Madam. Sri Somnath, Secretary Department of Space, Chairman ISRO, Dr. Pavan Kumar Goenka, Chairman InSpace, Dr. Radhakrishna, Dr. Anil Kumar, Sri Shankaran, Sri Ramakrishna, Sri Vinod, the eminent space scientists who have brought this country this shape, Dr. P.S. Goyal, Sri Kiran Kumar, Sri Shivan, Sri B.N. Suresh, many others from Department of Space who are present, and the scientists from various organizations, DRDO, most importantly, the eminent people who have all the way come from all over the world, particularly the chief scientist of NASA, Michelle Yeoh, and all others who are present, particularly the people from industry. Very good afternoon to all of you. And my heartiest congratulations to ISRO for organizing this international workshop on space situational awareness and space traffic management, which is a very, very important topic in the scenario which is evolving. And I should thank Chairman ISRO for giving me this opportunity to share some of the ideas with you today. I am only primarily talking about the space situational awareness, even though both the topics, space situational awareness and space traffic management, both are extremely important and which needs to be addressed at very high level internationally to see that the evolving situation is under control and everyone has a role to play and the society gets benefited and we are not getting too much restricted out of the lot of activity which is happening and probably which is little unregulated. So that's a very important aspect, whether it is the space situational awareness out of various known, declared, undeclared activities, or the objects which are created. That's one aspect which can be endangering to the various space assets which are there. Second, on the other side, on the traffic management, the orbits, the various control mechanisms, regulations, what are required on the orbits, and number of satellites, what need to be launched, and at the distribution of them at the various altitudes, creating the space for new launches and also for the test launches are again very, very important today. I think Shankaran was talking about the launch vehicles and finding a window for the launch vehicles. It's a very, very tough job. And particularly, it's of course true for the launch vehicles also. For the people in the defense side, when you launch the missiles, you have to see both not only going up and coming down also. And of course, you have to see the number of stages which are also going up. Even for the launch vehicle, probably second stage and third stage onwards, that is also valid, which goes again to this lower orbit related things. And naturally, you need to find the slot. I think you are getting now only 90 seconds, 70-second slots where you have to launch your missions, what are coming up. So that is what actually is concerning on the space traffic management is one very important thing. In fact, probably internationally, there have to be proper laws and proper mechanisms which need to be brought into the traffic management particularly. There have been, if you look at the last decade, in various universities and other places, the space law has been introduced. And people have been updating it as it is evolving. So there have to be regulations and they have to be imposed disciplines, not leaving it to the discipline of individuals. This is one of the important things probably which is required. And second, also I feel, yes, if for a given application, there are uh, 10 different organizations or 10 different uh, users or 10 different companies launching for similar applications and then making the space is becoming too dense is also one of the important aspects which has to be seen as collectively by everyone, how we can utilize the given space properly by all together in an integrated fashion. That's another important thing as far the space traffic management is concerned, which we need to look at it. So let me concentrate on the uh, space situation awareness. I don't want to mention. So lots of applications both in the civilian sector, and I don't have to mention to this audience here the growing needs, the societal benefits, and I keep remembering when the Department of Space started, and the first has been uh, thought about of the space and things like that. What great scientists like Sarabhai and all that mentioned, you can't imagine what the space is going to do to the society after 30 or 40 years. And nobody believed rather that time what it is. This is the dimension what you are going to have. And the dimension is changing day by day. Just today morning, I met in Bangalore about 3 startups. The numbers they were talking about the satellites were hundreds and hundreds and hundreds. So what we probably estimate, somebody says, what is the number of satellites we have today in the space and what is projected to in 2028 or 30, I don't think the numbers probably we are really predicting well, and probably we do not know what is the type of numbers going to be there. The other aspect on the military side, space has become the fourth dimension of warfare. This earlier we used to have only land, air, and sea. Space has become the fourth dimension of warfare. So a lot of military related and defense related activities have already started in a big way in the space domain. So that is again increasing a lot in the space activity and density in the space. So if you look at it, space situation awareness, various aspects of it, whether it is they were given specific purpose launched satellites which are known, or there are satellites which are launched for the defense purpose, or uh, the satellites are the objects which have completed their life, and the various objects which have been thrown in the part of these activities are the actual space objects, asteroids and other things, and also the activities which are concerned specifically in the defense domain, which are intentionally launched, which are kept, which are trying to see, and which are trying to uh, neutralize and things like that. These are all some of the important activities what have in the space situational awareness. Civil perspective, when you look at it, it's primarily for to see that various satellites are kept in the various orbits, and then there are objects which should not be creating any issues, whether it is 10 centimeters object or 3 centimeters object or 5 centimeters object or whatever it is, or the various space related objects, or there are any malfunctioning related assets which are there, or the vehicles which have been launched and which are actually the last stage which has been put into the orbit to launch the satellites are some of the issues which actually concerning this when we are trying to launch our own uh, trying to put our own satellites into the orbit and trying to see that they are safe and secure and various other things. Leaving aside other things, then the space weather is also space weather, space environment, monitoring about space environment and related aspects of it, and the causes what it can have, and so how to look at those angles and see that is another important activity primarily in the civil domain, even though it is applicable equally in the military domain. Coming to military domain, this becomes more and more important as there are conceived to be intentional activities. So then naturally you have to be more and more careful. You have to see various activities which are called ASAT activities, anti-satellite related activities, which you need to be careful. What are the things which are ASAT missile? Are there a core battle mission? There are a robotic arm related, or otherwise you have electromagnetic try to create and things like that, and all that is one of the things. There are many space related surveillance mechanisms which have come into existence today, whether it is LN, Common, SIGINT, and many other activities which you need to know what are the types of activities which are happening from the space, then you need to monitor those things from the ground. So these are all the some of the specific activities which come with respect to the military domain over and above the civilian domain. So these are all the some of the things which have been mentioned here. Now, if you look at it, Dr. Goenka has already mentioned number of satellites which are there in the space domain now, and what are the things, numbers which are going to be there by 2030, what are the debris available, what are the debris, the size is going to increase, numbers are going to increase, and all that is going to be enormous. That is what mentioned as 60,000, or I don't know what, it depends on anybody who takes up what type of activity he takes up, and who is not disciplined himself. Based on that, this debris and other things will be there. But the number of satellites probably, as I was mentioning, I'm not very sure. The numbers can be multi-folds if you look at 2030. So the numbers will be increasing a lot. Now, when you look at it, threats to the space assets, primarily I'm talking about both on the civilian side and also the military side. Civilian side, as you see that primarily the space debris or the space objects are some of the satellites which are actually malfunctioning, or some issues which are there with respect to that, or the vehicles, the launch, the spent stages and things like that is some of the things. Second is the anti-satellite tests and missions which can be taken, which are actually, one is demonstration things to prove or to see that the technology is established by some of the countries, or actually in a military domain, if there is a war scenario, what really activity takes up in the anti-satellite is some of the things. So when you look at it, some of them which have happened have been put here, sort of a things, and some of those other activities like co-orbital tests and things like that, are the space-based high-power lasers or space-based robotic arms, or as I said, docking, berthing things, are space-based high-power electromagnetics and things like that, are some of those things which actually are coming up. Then to this, I was as it is, I mentioned, high power RFL and high power lasers, jamming and whatnot, and all that, some of those activities which are connected to that. Then lasers and other things I have already mentioned. Then the space debris and challenging role of SSA. This is one thing which is very important today, which actually every space organization in any country is need to monitor the various space debris and the damage it can cause, predict the path of it, and see whether I need to maneuver my asset to escape from the debris effect. Is one of the very, very important activities which actually are seen by every nation. And of course, leaving aside the activities of low Earth orbit or medium Earth altitude orbits, are talking about geostationary. Some of the missions which are taken up for interplanetary missions, like what our ISRO has done, the Mars mission or Chandrayaan and all that. Then we need to look at various other this space objects which are in the universe and their travel, their path, their orbits, and predicting their orbits and seeing that these missions are not affected is one of the important aspects of it. So when you look at those things, so monitoring all these things is one of the important activities to see that the assets are protected, our assets are safe is one of the important activities. I don't want to get into the sizes and things like that, whether it is 10 centimeters object at geostationary. Yes, at geostationary orbit is also at 36,000, or you talk about at 50,000 HEO also. 10 centimeters object is very important, whether it is at that altitude or 500-kilometer altitude, the damage can be equal or maybe the impact may be very, very high. So these are some of the important things which we need to see. And then the ability to of anyone to actually put in surveillance and locate these objects and track these objects is one of the important things which probably in some of the slides I should be covering later. Now, if you look at the capabilities of SSA, various nations globally have been working, are working, and trying to improve their capability in the SSA, whether it is various radars or various electro-optical or telescopes related activity which is happening, which is again, I say, a continuously evolving scenario. As I said, whether you are tracking surveillance and tracking, these are two important activities. Surveillance, are you able to do at the altitudes what you are thinking? Or also as you are able to look into the universe when you are trying to have interplanetary motions or missions. So these are the things. So when you look at, do I have a radar which actually can look at an object at 50,000 kilometers, which is of 10 centimeter size, whether I have a radar or a telescope, or then taking the cue from one of them, whether I can track it, is one of the important aspects where research is continuously happening. If you look at various nations, either USA or Russia or China or European nations have been collectively working or individually working in developing these radars and trying to establish these sensors globally and trying to have some of them as consortiums sharing the data, because you wouldn't be able to see from one location, so you need to have at multiple locations, and looking at these objects is a very important thing. So these are some of the things which have been mentioned here by the various nations. Now when you look at the sensors, radars, again radars for surveillance and tracking, then talking about telescopes, uh, one is for having a surveillance and tracking at very high altitudes, like 36,000 kilometers, is one of the important things. And then, of course, providing the cue to the radars, which radar can track it continuously and trying to predict and see that that which I come to that topic little later about the orbits and things like that. And then various other things what I have mentioned, like alien comment. These are primarily for the, again, on the military applications. So military applications, there are, as I said, many of the surveillance systems which are coming up, uh, doing intelligence, as I said, to look at the radars, or they are also working for various other purposes from there, uh, trying to have various sensors there, which are important for us to track from the ground and see it. And even in the other side also, even in the civilian applications also, these are some of the things which actually people have been talking and trying to work, and some of them which have been actually planted also, or which have been incorporated also, space-based radars, space-based telescopes, or space-based multiple things. So these are also very important, which need to be seen. And so somebody wants to actually monitor these activities, then you need to have the capability to monitor them in a passive mode. So that is one of the important things what has been mentioned, lasers and lidars. And of course, space weather forecasting is also one of the very important activities, which actually some of the countries, some of the specific organizations have been working in this, which I'll be talking about it little later. So ground-based SSA radars, if you look at it, these are all the various radars, which varieties of radars. I'm not very sure whether there is a slide on it later, whether you talk about UHF radar or talk about VHF radar or talk about normal S-band type of radars, or huge size of radars based on the locations and things like that, are some of the activities which have been taken up, various countries have established, and trying to see that, trying to have space situation awareness within the country's capability. Meaning, one country may be more concerned and looking at only about low Earth orbits, and other countries may be going up to medium orbits or going up to geostationary. Now, if you look at the types of sensors, what are there, the various surveillance radars, these are all the various surveillance radars which are known to us in the public domain. Very many of the sensors which are there, as I was mentioning some time back, various UHF radars, VHF radars, and then you have also biostatic and L-band radars. Depending on the application, the range at which you are trying to have surveillance, at altitude at what you are trying to have a surveillance. Now, when you look at the tracking and imaging, these are the various sensors which various countries have incorporated. Again, when you look at it here, tracking, then naturally you get into S-band, X-band, and all other types of even KU-band, Ka-band, and various other applications of varieties of radars, which are trying to get it more into the tracking side, or some of them, of course, for the imaging side also. Then there are varieties of telescopes, which again have been established globally. Originally, it was primarily to see as a universe, to observe the various planets and other objects in the space, was the one which actually being used now, which we are trying to work more and more for space situational awareness, primarily around the Earth, from low Earth orbit to geostationary orbit, is one of the important applications which many nations are working, and many telescopes have been there, which have been there coming up in the last century onwards, and now trying to improve the various systems. So these are all some of the important sensors which have been put, which have been various nations have been trying to put it. I'm not getting into any specifics of this. Every nation is trying to put it and trying to see that they are able to monitor, do the surveillance, tracking of these objects, and then classify these objects is one of the important things. As I said, importance is surveillance and tracking, and then later predicting the orbit of it. So, if you look at the suitability of radars, yes, we know that radars are primarily for the low Earth orbit and probably maybe medium Earth orbit or sort of things. Very effectiveness of the radars today for the geostationary 36,000 kilometers and beyond and all that is very less, where the telescopes come into the picture and they play a major role, and then a cue from that telescopes is taken, and then the radars do the tracking later part of it. Now, this is one of the important aspects when we say after the surveillance, when you are tracking, we need to estimate correctly the orbit of that object. That is what is important for safeguarding our own assets. Are we able to predict this, or do we have the right algorithms? If the algorithm is able to take care of the various influencing factors, which are actually again the data which is being generated, based on that, are we predicting is one of the important activities where again the continuously these mechanisms, algorithms, formulations are continuously updated to see that you are able to predict it very accurately is the most important aspects. If I have an asset, if I'm able to, if the my asset total dimension on one side, let's say, is about 10 meters, so I need to predict the trajectory or the path of the orbit of the object to better than this accuracy. Then only I need to look at it, whether I need to maneuver it to escape from this debris or not is one of the important things, which we need to look at it and various this multi-sensor data fusion, and based on that, the algorithms which are being generated. Yes, today we can say that reasonably many mechanisms and algorithms which are there are able to reasonably predict well. The challenges in data processing, I don't want to get into it. Looking into many aspects of it which become the input to these algorithms. What are all each block what has been kept there influences this, and then we need to look at these and taking care of each and every aspect of it when we are actually predicting and when we are computing and orbital analysis and whatnot and all that we are trying to see. This is one of the again important things. I'm not getting into it, just given a gist of it to have a feel of how complex the situation is if you want to predict it accurately. Now then, asteroid tracking. This is another important things where different techniques have to be used, and each of the asteroid, how do you place yourself, how do you offset them, and try to predict that correctly, the path of it, and actual looking at the image of it, and your placement of yourself and corrections for that is one of the important activities, particularly leaving aside the around Earth when for the interplanetary motions and related aspects of it, what we need to look at it. Again, some of those radars which are used for this purpose have been mentioned here, where you are trying to track those things. Now, debris mitigation strategies, which actually a lot of countries, a lot of nations are working on this. If I'm right, maybe about 2 years back, ISRO has conducted a workshop on this subject again very specifically. So the space situational awareness, the accuracy of the prediction of that, and then one of otherwise you have small release from this, go goes and diverts it and moves it away. Of things, lots of thought processes in this are coming up, and even people are talking about to have a high power lasers and things like that, where you are actually able to kill that object or destroy it into small particles, sort of things and all that are multiple things and thought processes which are existing, which are working, and probably some more will be coming in the future. How you need to look at these things is some of those activities, and particularly importance is on the object having some of those things which you are able to throw to divert it or catch it or destroy it is one of the important activities many companies and many people are working in the world today. And again, as I said, if you look at the various probabilities of collision which have been kept here, and what is the impact of it, and how you your object can be in a endangered condition, is what has been put it here. And so, if you look at it, SSA role, cataloging, collision avoidance, space object re-entry estimation, space debris modeling, and whatnot, and all that are some of the important activities which get into the domain of space debris. Now, some of those things again in the military domain, these are again very important in the military domain, which are not actually getting into the civilian domain, which becomes important for the security of any nation, where you need to have all these capabilities, where you are able to detect a launch or a, a satellite has been launched which has specific payloads which are for the purpose of neutralizing our own assets, are some of those things which we need to look at. So, which calls right from the launch of a missile onwards, or launch of a, let's say, even a vehicle onwards, to monitor that. And finally, what is the satellite which has been ejected, and what capability it has got, and what types of a specific capability it has got, is one thing what we need to look at it. That is what is generally mentioned here, looking at various things. This is an important thing. As I said, if it is a missile has been launched and coming towards a satellite, and if you are not able to predict it, and you wouldn't be able to escape that particular phenomenon. So, need to be very, very clear in this monitoring these objects in the military domain. This is another important activity, space weather effects, which actually have lots of effects on. It is equally applicable for both civilian and military and various other aspects. Many nations are working on these, and there are specific organizations which are looking at it. Let it be solar storms, or let it be heavy ion and electronic movements, or ionospheric changes and related aspects, and multiple things which actually multiple organizations are working, like let's say the TIFR in our country, which works on these particular aspects, which leaks, because which actually can create lots of effects. There can be complete communication blockage. The complete data can maybe issue. There can be damage to the satellite itself. There is some of the components what we have used, and particularly uh, what is the type of radiation hardening and things like that, what they have, and all that is one of the things. Or GPS related timings, the effects of ionosphere, the time delays, what it causes for various pseudo signals and all that, what you have. So these are all some of the very important things, effects which it has got, which we need to monitor the space weather also equally. So this is when we say space situational awareness, space weather monitoring is also one of the important activities, elements of space situational awareness. Um, I think I mentioned this, I don't have to get into this. Um, when you look at it, SSA, typical military system which we are looking at, um, ground-based very long-range radars, ground-based passive systems which we monitor, the special sensors which are there on each and every space asset, and space countermeasures, and able to mitigate the effects of the missions like anti-satellite missiles or various other objects, are some of the important military domain activities. And as I said here, which when we monitor here, I was mentioning earlier, space-based radar, telescope, IR, LIDAR, LN, command systems and whatnot, and all that what you have, which we need to look at it. And many times today, generally, there have been sharing of the informations across the nations, the data what it is available, particularly for the civilian domain. Military domain, yes, many nations have not entered into it fully. So in the civilian domain, In fact, even a general public domain available like NORAD certifying or specific agreements are there between the nations which actually share the data, which are providing various things, including the space weather. So this is what actually generally the scenario which is there in the world today, trying to share the informations and provide these informations across. So actually for this community, I shouldn't be saying this, but then for the completeness sake, I should definitely mention the activities, what are happening in India, the various sensors, radars which are there, and what ISRO has taken up the activities for its own activities of the civilian domain related monitoring systems, whether it's Netra or some other systems which are coming up, various radars which are there across the country. And if you look at it, the mission Aditya L1 for monitoring the sun, and lots of activities are going on in the country. May not be looking at space situational awareness as such, but as for various other applications, looking at very long range radars for surveillance application, tracking applications, and various electro-optical systems or telescopes which are being built, and then lidar, lasers, and related various things are happening in the country in a big way. Lots of laboratories across working both in the civilian domain and things like that. If you look at it, the market today, which is expected to be becoming about close to 2 billions by 2030. This is expected to be. The figures could be much different. Different means much higher, not that much lower going to be. This is what is the market, what is going to be there in this, as the awareness among the community is becoming more and more. And we need to look at these aspects, which otherwise will create a lot of problems for this community to have the activities what they are thinking to go ahead. Before getting into this concluding today, one thing is all of us know it, one is space is getting congested. So that is one thing, the traffic management and other things, what I said in the beginning. So many speakers may be there who will be talking about it. Tomorrow, we may need a traffic management system much better than what we have the civilian aircrafts today, what we have. Much better maybe system what we need to have worldwide, globally, looking at those things. There is one thing. Looking at the space situational awareness, again, as I said, as the global community of space, we need to look at it and try to evolve ourselves how to see that the space is protected, the assets will not be are in safe condition, and there are uh, regulations or laws or unwritten laws which all the entire community follows it, and see that all of us are able to fill in. Let's say any space mission, how do we see that there are which creates zero debris? One thing can work technologically to see that any mission creates zero debris, and whatever it is happening and well known, and the other spent stages and all that can be brought back and will be brought back and properly and all that technological solutions which are very much feasible, I feel. If it's only that the community has to look at seriously those aspects and see that we are working for that cause, and then definitely we should be able to see that. And also there are no intentional debris are created is another one of the important activities what can be seen. Similarly, entire globe, entire all the nations in the world are sharing the entire information across to see that no asset is affected by anyone, and that sort of an agreement internationally this community can come across. And there are stations which are called international stations which can provide the informations, giving the entire information about the space debris, or as I said, asteroids and things like that and all that. Then some sort of a understanding among all of us to come to see that the whole as a space community in the globally, we are all disciplined, and there is mechanism which ensures that These are all these what we thought are bare minimum. And also, I also say that there is enough space in time domain or physical space domain available for the new launches or the new tests, what is supposed to be happening, which also probably need to be thought about. And similarly, too much of a density of the satellites between 450 to 650 kilometers, can we also reduce that density too much? Can we see that we have some sort of a mechanisms, management and other mechanisms which can be brought in, that we are displaced altitude wise, and then the effects of it or the causes of it, like cost and other things, how can they be taken care of? There are advantages and disadvantages both, which can also be looked at it. These are all the top level issues which we need to look at it as a community and see that these things are also brought in globally. Coming to our side, we need to, as a country here, India, we need to take as a important, serious mission, both particularly the civilian domain satellites in all aspects, particularly now the communication related and other aspects, number of satellites are going to be large in number. Yes, even though we have today 59 or 60, I'm sure this is going to be more than thousands in the coming maybe 4 or 5 years is the numbers what we are going to have. We need to look at it to see that, to safeguard our assets what we are having, and which again at various orbits, low Earth orbit and medium Earth orbit, or geostationary and related aspects, we need to look at it and try to have our own sensors and try to, yes, naturally if we have a very good sensor here, then naturally other countries also look at it for the information sharing, and so naturally there is a reverse information flow also happens. So we need to develop our own sensors and assets which can be used for SSA. And most importantly, in this particular aspect, we know Honorable Prime Minister is very, very clear, which he has given the call for Atmanirbhar Bharat. For the people from outside, Atmanirbhar Bharat is self-reliant India, meaning you are able to design, you are able to develop, and you are able to manufacture here in the country, and you have such critical systems are developed here in the country and put into service, which actually world also recognizes and then equally shares the information with you. So which is important for the people who are from this country, who are part and parcel of here. We need to look at it, what systems we need to develop, sensors, both ground-based, space-based, and then mechanisms, algorithms, and various techniques, what need to be developed. We need to look at it is one of the very important aspects. I'm sure that these 3 days will have in-depth deliberations on each and every aspect, should be able to come out with very strong recommendations for this community to implement that, to see that space is utilized for the benefit of this society. Thank you very much. Jai Hind, Namaskar.
Thank you, sir, for enlightening us on the current scenarios, challenges, and need for SSA in various perspectives and its way forward. I request Dr. A. K. Anil Kumar to escort all dignitaries to the dais. Yeah. May I now request Secretary DOS, Chairman ISRO, to kindly present a memento to Dr. G. Satish Reddy. I request Akansha to assist.
Thank you, sirs. Thank you. We now continue with the other talks. Sri D. Radhakrishnan, as we all know, is the chairman and managing director of the New Space India Limited, NSIL. an aerospace engineer with more than 33 years of experience in handling space programs and projects. He specialized in rockets, satellites, commercial space business, and international marketing, launch services, communication based services. We're glad to have him here with us today. May I now request Sri D. Radhakrishnan to kindly address the gathering.
Thank you very much. First of all, let me extend, I think after such a hearty presentation by Dr. Satish Reddy, I think the subject he has covered, we're left with not much of a topic to discuss. Anyway, formally, let me just extend a very warm welcome to all the distinguished dignitaries from India and abroad to this important workshop on space situational awareness and space traffic management being organized by Indian Space Research Organization, ISRO, Aeronautical Society of India, InSpace, and New Space India Limited. If you look at the event of this kind that we are all present here, especially the theme that has been selected for this particular workshop, I think I'll not be wrong if I say this is the first of its kind being organized in India in such a large scale. The fact that such a theme is being selected and such a workshop is being organized on this particular topic basically shows the kind of prominence and attention this particular subject of space situational awareness is gaining in recent times. And it has been quite phenomenal just because the kind of space activities that has been growing world over, they are going not only leaps in bounds, but I think it's in a great magnitude. Uh, this particular activity is taking shape. Now, if you look at the space situational awareness, I know a lot of topics will be discussed in depth during the 2 to 3 days of conference. But in my perspective, if you look at the space situational awareness, it has been playing an extremely significant role in ensuring that the space activities are carried out extremely safely in accordance with all the domestic and international laws, standards, and the applicable norms that are relevant in this particular area of activity. Now, what is important is that one need to better understand the space environment. I think Dr. Satish Reddy talked about the space environment aspects. I think that is one of the very critical item that one need to understand and should be aware of the likely threats that it is going to pose to the space activity before it is undertaken. So what is that we are trying to address through the space situational awareness is quite basic in my perspective. They are issues related to orbital collisions that we are talking about between space objects, can be even space debris, and what are the mechanisms that you have, just you are trying to mitigate these particular aspects. Now, if you go back a little bit into the history, since the launch of the first human-made object in way back in 1957, when this Sputnik was launched, all of you are aware, I think during the 60s to the 2000 time frame, we would be seeing only a couple of satellites getting launched every year. I just looked at some of the statistics just to get a feel of what is the kind of numbers that are looking at. The numbers indicate since the launch of the first object in 1957, the number of satellites that were getting launched into orbit, if you look back, say 10 years down the line, somewhere around 2010, the numbers look something like 80 to 100 satellites per year globally. Now, if you look at the present scenario, which is around 2020, with a lot of constellations and both Earth observation and broadband constellation coming up, the number has increased almost 10 times, I would say. And what the literature indicates, by 2020, the number of satellites, which were around 80 to 100 in 2010, has become almost like 1,300, 1,400 satellites getting launched every year. So if we little bit dissect on what exactly is the reason for this increase, I know the applications are increasing day by day, but I think first and foremost thing that really comes to my mind is basically the number of satellites that are getting increased day by day is with the entry of these small satellite configurations. Now, when you talk about these small satellites, we find one of the biggest advantages quickly realizable. We are able to realize the satellite in a very shortest period of time and in extremely large numbers. And once the satellites are getting realized in such large numbers, if you see on the other side, the carrier, which is nothing but the launch vehicle, your capability of launch vehicles to carry several satellites in one mission, and most importantly, in a very affordable cost, is making this entire game of multiple satellite launches in recent times. So I would say, like I mentioned, the exponential growth of the satellites in LEO, especially in LEO, though initially it was related to Earth observation constellation, I think of late, I would say maybe just 3 to 4 years or 5 years down the line, it has been primarily because of the mega LEO constellation of broadband connectivity. And I think I would also say it is no guess with time the number of the satellites in LEO are going to grow much faster. Now, if you look at in the present context of increased space activities, space situational awareness, space traffic management are going to play a very important and dominant role in ensuring that space environment is kept well protected and, more importantly, reasonably utilized. As far as the capability, if you look at the type of capability that exists globally, not many countries possess this capability and expertise to be the SSA service provider, as it requires a significant ground infrastructure, both hardware and software, I would say, and most importantly, the core technical and niche expertise to be successful in this arena. And I'm also glad and happy to say that ISRO has recently established a dedicated SSA control center in Bangalore, which is fully functional and providing services. Now, as I represent New Space India Limited, which is a commercial arm of ISRO, obviously we'll also try to look at what is the commercial dimension of this particular activity. So I will be happy to say, I think with the permission of all the senior colleagues here, that we'll be happy to provide SSA services on a commercial basis to various global stakeholders who are into, I would say, satellite and launch businesses. In fact, I think Dr. Satish Reddy already mentioned, I also had a note which says commercial SSA service provider services is a big commercial market, 1.4 billion, I think currently, and likely to go up to 1.8. And there is expected to be quite a good number of commercial opportunities that are going to come up. Now, before I conclude, I would also like to say that in the Indian context, we have a lot of colleagues from the Indian industries. The topic of SSA and STM is going to be very relevant, as there has been an increase in the number of Indian and private players who have been motivated, especially to take up these space-related activities post-space sector reform that has been announced by Government of India. And of late, we are also seeing that many private industry players have been coming up with innovative concepts of removing the existing space debris and also looking into providing newer technology solutions where creation of newer space debris is prevented. I know a lot of technology innovations are happening both in the satellite and launch vehicle sites, where the people are looking at how to bring back the satellite after end of life, and also the mechanism where the upper stage of the rocket is also brought back to the ground so that we don't create any further debris. So let me just conclude and say thank you very much for the opportunity, and I wish the event a very grand success, and request everyone to also find some time to explore Bangalore and the surrounding areas in the midst of all the engagement that you have during this conference. Thank you very much.
Thank you, sir, for a very informative address and conveying the commercial collaboration perspective. Sri B.N. Ramakrishna, Director STRAC, has been the guiding force behind the conduct of this event, lending every support required by the organizing committee in conducting this program. Sri B.N. Ramakrishna, a spacecraft specialist, is currently leading the STRAC, which is a major ground segment provider for many space missions and launch vehicle support, which is also handling the radar and space situational awareness program. We are glad to have him here with us today. I request Dr. B.N. Ramakrishna to kindly address the gathering.
Thank you. Good evening to Chairman ISRO, to Scientific Advisor, to to Raksha Mantri, Chairman InSpace, Director URSC, Director CMD NSIL, and my colleagues here, Anil Kumar and Vinod, and former chairmen and other dignitaries. I am very much delighted to be part of this important international workshop, which is very apt today, where we are discussing the space situational awareness and space traffic management, and really the growing concerns we are going to discuss in the next 2 days. As you all know, space arena is largely dominated by some of these few nations, and due to the advancement in technology and growing interest in space exploration for commercial purpose, I would like to say commercial purpose, the uh, number of satellites and other space objects have increased exponentially. As my earlier speakers have already mentioned the numbers, so it is really a concern today for all of us. Such changes, while presenting new possibilities of reaping benefits of humankind, also pose unique challenges to the long-term sustainability of our activities, space activities. So, with an unabated increase in the number of satellites, how to manage the uh, space bodies or satellites with low risk of collision is a real challenge today. As we all are experiencing already in our current satellite operations, we are coming across multiple collision avoidance maneuver requirements. As already mentioned earlier, we are seeing something like 15 to 20 per annum, but the graph when you see, which was about 1 or 2 per annum, has increased and it is growing exponentially with many of the satellites in orbit. To mitigate this problem, ISRO has made a commendable progress and built expertise in analysis related to space situational awareness. And recently, we have started ISRO system for safe and sustainable operations management, which we call as IS4OM. This has been established to synergize ISRO towards space situational awareness and space traffic management to safeguard ISRO space assets with the space debris. Under the aegis of ISTRAC, SSOM is spearheading and establishing of space surveillance network with host of radars, telescopes across India, and an operational system has been planned in the SSA control system for detecting, analyzing, mitigating the risks of space assets through these sensors. SSOM is further going to expand with the scope of its capability by taking space weather studies, near-Earth objects, and planetary defense studies. In addition to collision risk avoid assessment and mitigation, SSOM is also instrumental in data exchange and collaboration with other space operators and space agencies and contribute significantly to the rising awareness among emergent space actors. So this workshop is a culmination of one of the such endeavors where we want to have the understanding of space situational awareness and space traffic management. Knowledge sharing is the crux of SSA. As all of you know, it is not like one object we are going to track, it is going to be thousands of objects. So we require to share the data, the knowledge across the countries. And this workshop is an excellent opportunity to harness the expertise with the invited speakers across the globe who are stalwarts in their respective fields and have kindly accepted our invitation to share their wealth of knowledge and decades of invaluable experience. We eagerly look forward to the technical sessions to improve our understanding of the subjects through interaction with them. As you know, private industry plays a very, very important role in building the capabilities so that would shape the future space environment to a great extent. Public private partnership will not only help in enhancing the existing SSA STM capability across the world, but will also help in arriving effective solutions for future challenges of the space domain. This workshop, a unique platform for emerging Indian private industry to contemplate developing technologies and capabilities that will help India attain self-reliance or Atmanirbharata in essential and niche areas like space situational awareness and space traffic management. I am very happy to note that one of a kind of workshop, as already told, this is the first of its kind being hosted by ISTRAC. As director ISTRAC, I have seen tremendous efforts put by all our team to realize this workshop since 1 year almost. The scale and range of participation in the workshop are reflective of ISRO's commitment towards enhancing its SSA and STM capabilities. The level of participation from the industries and academia also highlights the growing interest of non-governmental entities in realizing this capability indigenously. I commend the organizers, the participants, the speakers, and all dignitaries for giving our private space industry a very timely opportunity to explore, assess, and evaluate their potential and areas of interest in SSA and STM. I have no doubt that the ideas and discussions emerging from this workshop will contribute to laying out of a roadmap for providing practical solutions for future challenges. Thank you. Jai Hind. Let's hope we'll have a good 2 days workshop. Thank you.
Thank you, sir. Thank you, sir. Thank you, Director Strack, for that inspiring and informative talk, highlighting ISTRAC and ISRO's contribution towards ISOOM and SSOM, especially in addition to the other SSA activities. Dr. Vinod Kumar, Executive Secretary of ASI and Director for InSpace, has been instrumental in hosting this conference. He has made untiring efforts in organizing such a wonderful event. Let us welcome Sri Vinod Kumar to deliver the vote of thanks.
Thank you, Madam. Respected Sri Somnath, Secretary DOS, President ASI, Honorable Dr. Satish Reddy, he has left anyway. Our beloved Dr. Pawan Goenka, Chairman in Space, dignitaries on the dais and off the dais, my dear friends and ladies and gentlemen. It's my privilege to have been asked to propose a vote of thanks on this auspicious occasion of inaugural function of the workshop on SSA and STM. I, on behalf of Indian Space Fraternity, extend a hearty thank to our beloved Secretary, Department of Space, for providing all necessary guidance and taking personal interest in designing this unique workshop and gracing the occasion in spite of busy schedule. We are all inspired by your presence, sir, and great words. The Indian Space Fraternity, I will say the new Indian Space Fraternity is overwhelmed by the presence of Dr. Pawan Goenka, Chairman in Space, we thank you for delivering a special address and gracing the occasion, sir, in spite of busy schedule. I must mention our deep sense of appreciation to Director URSC and Director STRAC for encouragement, support, guidance, and valuable suggestion at every stage of planning this workshop and explaining the theme of the workshop also. Thank you, sir. I would like to take this opportunity uh, to thank all the organizing committee members for careful planning and executing it so well, and of course, industry partners and sponsors of this conference. Well, ladies and gentlemen, an event like this cannot happen overnight. The wheels start rolling months ago. It requires a planning and bird's eye view for the details. We have been fortunate enough to be backed by Dr. Anil Kumar, a very motivated and dedicated gentleman. We appreciate your guidance and support at every stage, and of course, planning the curriculum of the workshop and inviting speakers from around the globe. We thank you, sir, for all this. And we have some introduced at the last stage some good session on industry and academia. I should compliment and thank all the academia basically and industry to come forward to be a part of this. It is on 13. Please be watchful. They are preparing well. I say that we have tried to make our hospitality arrangement best, but there is a Sanskrit saying that Sukharti va tajet vidyam vidyarthi ya tajet sukham. So please make use, leave the comfort for time being, maybe for just 2 days, but you will learn a lot. I must thank all the members of organizing committee, subcommittees, and ASI team members. You all are really committed. You come forward to take up any challenge. My sincere thanks to all of you. My vote of thanks will not be complete without thanking all the supporting staff responsible for awesome logistic arrangements, for safe driving us to the venue, and they will be with us all 2 days. Videographies, catering, security, etc. I must mention that invocation song was so well. It is. I thank you, Mr. Raghavendra ji from STRAC. Finally, ladies and gentlemen, once again, I want to state that we are almost grateful to all the dignitaries present here. We thank you for being with us, sir, this evening, and we expect you other 2 days as well. It has been a great pleasure and enjoy your participation. Jai Hind. Thank you.
Yeah, thank you, sir. With that, we have come to the end of this inauguration session. Following the national anthem, we will have an inauguration of exhibition by the dignitaries, during which all the delegates may remain seated here and watch the live stream. May I now request everyone to kindly stand up for the national anthem, please.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, ladies and gentlemen. I now request Secretary DOS, Chairman ISRO, to kindly inaugurate the exhibition. I request Chairman Organizing Committee to escort the dignitaries to the exhibition area. All delegates are requested to kindly remain seated here and watch the live stream. We will start the next session in 30 minutes from now.
Here, that is that remote. Keep completely whatever. But when you are coming here to explain, when you are showing this now, you can work on something else. In few minutes, we are going to start the next session. We request all the delegates to please be seated. And the few minutes, we may start the next session. We request all the delegates be seated here.
The inaugural session, the inauguration of the exhibition is over, and the dignitaries are expected back in a few minutes. I request the audience to kindly be seated.
Request all delegates to be seated here. We are going to start the next session soon. Request you to call your colleagues also if they are outside. So we are back here for an interesting session. We have now introduction of plenary speaker by Mrs. K.L. Shivani, Deputy Director of Communication and Control Center Area of STRAC ISRO. Also as a chairman of the Event Management Subcommittee, she has been leading the charge from the front. May I request Mrs. K.L. Shivani to introduce our plenary speaker, Dr. J.C. Liu.
Good evening to all dignitaries and distinguished guests on the dais and after dais. A journey of 1,000 miles begins with a single step, quoted by Luzu. So, can we consider this initiative by the space community as that first step towards the space debris management? We now have the very first technical talk of this workshop, which will be followed by several sessions by a wide range of experts in this field in coming next 2 days. It's my privilege to introduce to this August gathering Dr. J.C. Liu for the open plenary talk on orbital debris, space situational awareness, and space traffic management. Dr. J.C. Liu is the Chief Scientist for Orbital Debris and Program Manager for NASA Orbital Debris Program Office, which is a delegated program under NASA Headquarter Office of Safety and Mission Assurance. Dr. J.C. Liu has conducted research on orbital mechanics, dynamics of asteroids, comets, and interplanetary dust. He has more than 20 years of experience on orbital debris environment modeling, in situ measurements, laboratory impact test, and mitigation policy development. He is the head of NASA delegation to the Interagency Space Debris Coordination Committee, member of the US delegation to the United Nations Committee on the Peaceful Uses of Outer Space, and also a member of its Scientific and Technical Subcommittee. Dr. J.C. Liu earned a BS in Physics from National Central University in Taiwan and attended University of Florida for both his master's and PhD in astronomy. He was a US postdoc fellow at NASA Johnson Space Center before joining Orbital Debris Group. Dr. J.C. Liu has received several major awards from Lockheed Martin and Jacobs, NASA Astronaut Silver Snoopy Award, JSC Director Commendation Award, and the NASA Exceptional Engineering Achievement Medal. That was only a brief introduction about Dr. J.C. Liu, who has many more achievements to his credit. This gathering is delighted to hear his talk on the theme of this workshop. We are honored to have him with us today. I request Dr. J.C. Liu to take the floor, sir. Thank you.
Okay. Thank you for the introduction. Good evening, everyone. Let me first thank Dr. Anikuma for organizing this wonderful workshop to bring the international community to India to focus on space situational awareness and space traffic management, a very important topic. I also would like to thank Boba for making the arrangement for me, and Mr. Hani Gupta, who went shopping with me this morning. because my luggage decided to spend some extra time in Frankfurt, so I went shopping this morning. So now back to my presentation. You can see I added orbital debris to the mix or the title and have a subtitle of managing risk from orbital debris. The reason is very simple. How we manage risk from orbital debris is essential and critical to the success of space situational awareness and space traffic management. Before I make my point, let me ask the fundamental questions. What is space situational awareness? What is space traffic management? So, although there are different ways to define SSA and STM, in general, they are similar in nature. So here are the definitions in the United States National Space Traffic Management Policy. The ultimate goal of SSA and STM is to support and enhance safe, stable, and sustainable space activities. Please keep that in mind as I go over the orbital debris problem next. The human space activity started with the launch of Sputnik by the Soviet Union in 1957. Sputnik was a small sphere with several antennas. It only lasted 2 months in space, but that was the beginning of the space age. Since that time, close to 6,000 launches have been conducted by countries and organizations around the world. Today, we all enjoy many social and economic benefits from space activities. Unfortunately, the space activities have led to a side effect, a pollution to the space environment, orbital debris. This is a visualization of the growth of the orbital debris population over time. The upper left corner shows the environment before 1957. The lower right panel shows the environment in 2022. Each panel has 2 simulated images, a close-up view of the Earth to the left, and the zoom-out view to the right. We can see additional concentrations of orbital debris in geosynchronous and other regions. This illustration shows that the space environment was nice and clean before 1957. But the space activities since that time have created the orbital debris problem. And the problem is getting worse. And the white dots here, they are objects in the US satellite catalog. In general, these are objects about 10 centimeters and larger. The term orbital debris is used to describe any human-made object in orbit about the Earth that does not serve any useful purpose. There are different sources of orbital debris at different site regimes, as you can see here, from debris as small as 10 micrometers to as big as 10 meters in size or larger. The top 3 are the major components. They include spent upper stages, retired spacecraft, mission-related debris, and breakup fragments. Fragments generated from explosions or collisions associated with upper stages or spacecraft. There are additional components in the mix, but we can all trace them back to upper stages and spacecraft. Meteoroids or micrometeoroids also exist in space. They come from asteroids or comets, but we do not consider them members of the orbital debris family. So how much debris is currently in space? The biggest objects, about 10 centimeters and larger, they are tracked by the Department of Defense. The Department of Defense, using their global sensor network, they track currently about 47,000 objects, big objects in the environment. About 27,000 of them are 10 centimeter and larger. Now, 10 centimeter is slightly larger than a cricket ball. But the orbital debris population is not limited to the big track objects. The big track objects only represent the tip of the iceberg of the orbital debris populations. There are many more debris too small to be tracked, but still large enough to threaten human spaceflight and robotic missions. Additional ground-based 1,000 at the 1 centimeter level. The population is on the order of 100 million at the 1 millimeter level. So why do we care for such small debris? The average impact speed between two orbiting objects in low Earth orbit is about 10 kilometers per second, which is more than 10 times the speed of a bullet. And because of such high impact speed, even sub-millimeter debris can be a serious problem for space missions. For example, a piece of debris as small as 0.4 millimeter can penetrate certain places of the suits the astronauts wear when they go out and conduct a spacewalk and threaten the safety of the astronauts. A piece of debris as small as 0.4 millimeter. And because the orbital debris population follows a power law size distribution, meaning there's more small debris than large debris, as you can see from the numbers here. Mission ending risk for most robotic spacecraft is actually dominated by small millimeter-sized orbital debris. I will come back to this very important point later. In terms of mass, the amount of material in space has exceeded 9,500 metric tons, and about 4,000 tons of the material is in low Earth orbit, which is the region below 2,000 kilometers altitude. So how did we get to where we are today? This chart shows the historical increase of the catalog populations. The top curve is the total number of objects as a function of time. The four curves below the total represent the population breakdown. Fragmentation debris in magenta, spacecraft in blue, upper stages or rocky bodies in green, and mission-related debris in orange. Fragmentation debris has dominated the population almost from the very beginning. The three major jumps, the peaks, they are from the anti-satellite ASAT test conducted by China in 2007, the accidental collision between Iridium-33 and Cosmos 2251 in 2009, and the ASAT test conducted by the Russian Federation in November of 2021. For spacecraft, the blue curve, there are about 3,000 retired spacecraft and about 7,100 operational spacecraft. The current increase, the recent increase in the spacecraft curve is due to CubeSats and large constellations. As I mentioned earlier, the catalog objects only represent the tip of the iceberg of the orbital debris population. There is more small debris on the order of 100 million that can threaten the safe operation of space missions. The orbital debris number distribution is dominated by fragmentation debris. However, when we look at the history of the mass increase, the distribution is quite different. Again, the top curve is the total, and the population breakdown is represented by the 4 curves below the total. As expected, the mass distribution is dominated by rocky bodies or upper stages and spacecraft. And from the trend of the mass increase, you can see there's no sign of slowing down. And this is a very, very serious problem. As we continue to add more material to the near-Earth space environment, we will only increase the potential of having more accidental collisions in the future to trigger a collision cascade effect, the so-called Kessler syndrome. The distribution of orbital debris is not uniform in space. Here we are looking at the spatial density of the catalog objects as a function of altitude. Low Earth orbit has the highest concentration, followed by the geosynchronous Earth orbit region, which is about 36,000 kilometers altitude from the surface of the Earth. Low Earth orbit has the highest concentration of orbital debris and the highest concentration of operational spacecraft. NASA, we operate the International Space Station, the Hubble Space Telescope, and other spacecraft, such as the A-Trend Earth Observation Constellation in low Earth orbit. This chart shows the increase of the catalog objects from the year 2000, which is the bottom black curve, to the year 2010, the middle blue curve, to the end of 2022, the red curve. The increase from 2000 to 2010 was driven by 2 events: the ASAT test conducted by China in 2007 and the collision between Iridium-33 and Cosmos 2251. Those 2 events more than doubled the debris population below 1,000 kilometers altitude. The increase since 2010 from the blue curve to the red curve below about 600 kilometers altitude was due to CubeSats and large constellations, especially SpaceX Starlink constellation at 550 kilometers altitude. The Starlink large constellation currently has more than 3,000 spacecraft there, and the number will continue to go up in the coming months and years. How do we protect our mission from the large track objects, the 10 centimeter and large objects? The International Space Station is a critical NASA asset. Protecting the station and astronauts is a top priority for the agency. How do we protect the International Space Station from orbital debris? The Department of Defense tracks the large objects in space and provide conjunction assessment services to operators around the world. A conjunction is simply a close approach between 2 orbiting objects. The DoD or the Space Force can predict the trajectories for most of the track objects about 3 to 7 days in advance, and of course with some uncertainties. If we see one of the track objects is coming near the space station with a high collision probability, say 24 hours from now, we can fire the engine of the International Space Station to move the station away from the incoming object. The space station has conducted 33 such collision avoidance maneuvers against the large track objects since 1999, including 3 times in 2022. There is a similar process in place to work with the Space Force in conjunction with NASA's robotic spacecraft. How about collision risk from orbital debris too small to be tracked by the Space Force? For really small orbital debris, hypervelocity impact shields have been developed and implemented to support human spaceflight and robotic missions. But there is a cost to add impact shields, and there is also a mass and volume penalty to add impact shields to protect a system or subsystem from small debris impacts. For very small orbital debris, the space station is protected by different impact shields. As a matter of fact, about 500 different impact shields, as you can see from the illustration here. The US modules of the International Space Station are equipped with shields that can protect the module from impacts by orbital debris about 1 centimeter and smaller. Different space station modules have different shielding designs. The Russian modules are not as well protected. The Russian modules are only protected against orbital debris about 2 millimeters in size. Therefore, the real threat for the International Space Station comes from orbital debris too small to be tracked by the Space Force, 10 centimeters and larger, but large enough to penetrate the protection shields. And for the Russian modules, it's anything between 2 millimeters and 10 centimeters. For robotic spacecraft, protection against small orbital debris is not as good as what we have for the International Space Station. In general, millimeter-sized orbital debris represent the highest penetration risk to most operational spacecraft in low Earth orbit. If you look at the key components of a spacecraft, for example, in this case, the JPSS-1 spacecraft, the highest penetration risk is to the fuel tank, the green part here in the illustration. The highest penetration risk to JPSS-1's fuel tank comes from orbital debris about 1.3 millimeters in size. Currently, more than 400 missions operate at 600 to 900 kilometers altitude, including 18 NASA missions. Unfortunately, there is a lack of measurement data on the millimeter-sized orbital debris above 600 kilometers altitude. And this is a critical space situational awareness gap. Risk management without direct measurement data is a big no-no. There is a need to address this critical data gap. Let's now take a deeper look at the orbital debris problem and how to better preserve the space environment. The orbital debris problem is actually twofold, long-term and short-term. The long-term is the historical increase of the debris population and the expectation that the population increase will continue into the future. The trend of the debris increase does not look good, as I showed you earlier. So this is the long-term problem. For satellite operators, the debris population increase 50 or 100 years from now is not their most urgent concern. Satellite operators are facing a short-term problem, which is a threat from orbital debris to their operational spacecraft, which typically lasts 5 to 10 years. So let's look into the reason behind the long-term and the near-term problems and the challenges to protect future missions and preserve the space environment. The long-term problem is illustrated by this chart, the history of mass increase. Here, I show you the breakdown in terms of different altitude regime, low Earth orbit, medium Earth orbit, geosynchronous Earth orbits, and above. Despite decades of efforts to limit the generation of new orbital debris, the mass in orbit continues to go up. There's no sign of slowing down, as I mentioned earlier. This really underlines the potential of a collision cascade effect. The mass increase will lead to more external collision, which will trigger more collision because of the debris generated and go into a collision cascade effect down the road. We do have good policies, guidelines, and best practices in place to limit the debris population increase. They have been established since 1995, as indicated by the green triangles. First by NASA, then US government, and the international community, including the IADC and the United Nations. The problem is the global space community is not doing a good job to follow the established best practices, and that is the root cause of the long-term orbital debris increase problem. For example, we developed the 25-year rule in 1995. The 25-year rule means that at the end of mission operation for a spacecraft or an upper stage, you lower its orbit so that the drag force in the atmosphere will force the vehicle to naturally decay in 25 years or less. The 25-year rule is an effective and achievable way to limit the long-term presence of spent upper stages and retired spacecraft in low Earth orbit. Unfortunately, the global compliance level with the 25-year rule has been very low, less than 40% over the past 15 to 20 years. Every year, 5, 10 or more spent upper stages and retired spacecraft are left at altitudes with very long orbital lifetimes in low Earth orbit, which will increase their probabilities of colliding with other objects in the environment to create even more debris. This is a very serious problem. Operators around the world need to do a better job to follow existing orbital debris mitigation guidelines and best practices. I will show you 2 examples of orbital debris mitigation best practices. The first is to limit post-mission orbital lifetime for structures operating in low Earth orbit. The COPIUS guideline is very high level and qualitative. The language is to simply avoid long-term presence of upper stages and spacecraft in low Earth orbit. The COPIUS LTS guidelines do not address this post-mission orbital lifetime limit. The IADC guideline, on the other hand, is very specific, quantitative, and measurable. It established a 25-year limit for post-mission orbital lifetime. The next example is about limiting human casualty risk from re-entering upper stages and spacecraft. The COPIUS guideline is again high level and qualitative. It is about not posing an undue risk to people or property. The language in the LTS guideline is similar to minimize risk from surviving components. The IADC guideline, again, is very specific, quantitative, and measurable. It set a limit of 1 in 10,000 for re-entry human casualty risk. If a structure cannot meet this threshold, then a controlled re-entry to target the broad ocean area is needed. Let me turn the topic to environment management. Active debris removal has been a popular topic in recent years. It is really about environment management. How do we manage the long-term orbital debris problem? There are 2 different approaches to manage the long-term orbital debris problem: prevention and cure. Prevention is mitigation. The technical community uses the term orbital debris mitigation to describe efforts to limit the generation of new and long-lived debris. Dealing with objects already exist in the current environment is not mitigation. There are about 2,000 spent upper stages and about 3,000 retired spacecraft in the current environment. Most of them will not decay anytime soon. We use the term remediation to describe efforts to deal with such objects. And there's only one way to get rid of those objects, which is active debris removal. So there are two aspects of long-term orbital debris management. Just like healthcare management, prevention and cure, for orbital debris, prevention is mitigation and cure is remediation, which is active debris removal. We will need both eventually, but the current priority is on orbital debris mitigation. It is easier and cheaper to deorbit an upper stage or spacecraft at the end of mission operation with sufficient fuel. Trying to remove an upper stage or spacecraft later with another mission is very difficult and very expensive. For example, the European Space Agency is planning to conduct an active debris removal called Clean Space 1 in 2026. The target is just a payload adapter ring with a mass of 112 kilograms. And the price tag for that mission is 100 million euros. There are more than 2,000 spent upper stages and retired spacecraft with a total mass of more than 1,700 metric tons in low Earth orbit. What is the cost to remove, say, half of them? If the price tag to remove a 112 kilogram adapter ring is 100 million euros. The bottom line is large-scale active debris removal for meaningful environment remediation is cost prohibitive based on today's technologies. Removing one object or 50 objects has little benefit to the environment. Another complication for active debris removal is the ownership issue. Close to 60% of them belong to Russia. In addition, as I mentioned earlier, the global compliance with the 25-year rule has been very low. Every year, the global community continues to leave 5, 10 or more spent upper stages and retired spacecraft at altitudes with very long orbital lifetimes, like centuries or longer, in low Earth orbit. Every one of them will likely become a target for future active debris removal, which is difficult and very expensive. So the message here is, let's stop the bleeding first. Mitigation is the priority. So this chart shows the top 500 high priority targets that we identified in a paper published 12 years ago. For meaningful environment remediation, removing the top 500 may not be enough, but it will certainly help. So each target here is represented by 2 points, apogee in red cross and perigee in blue circle. This way you can see the concentrations in altitude versus inclination of the high priority targets. In the paper, we identify 3 major classes of vehicles. The first is SL-16 Zenith second stage with a dry mass of 8.9 metric tons each. There are about 20 of them at around 850 kilometers altitude. The other 2 major classes are SL-3 Vostok second stage and the SLA Cosmos 3M second stage, 1.4 metric tons each. And there are more than 200 of them concentrated at different altitude versus inclination locations. The fundamentals of the low Earth orbit environment have not changed significantly since 2011 when we published the paper. These high priority targets are still valid for today's consideration. And as you can see, most high priority targets belong to Russia. For satellite operators, their number 1 priority is to ensure the safety of the spacecraft over the mission duration which is about 5 to 10 years. As I mentioned earlier, the orbital debris population follows a power law size distribution, meaning there is far more small debris than large debris. And as you can see from this notional size distribution of the debris population crossing low Earth orbit, there are about 10,000 debris larger than 10 centimeters. Again, here we're just talking about object crossing low Earth orbit. About 250,000 debris larger than 1 centimeter, and tens of millions of debris 1 millimeter and larger. When a 10 centimeter or larger debris impacts an operational spacecraft, the outcome is the catastrophic breakup of the vehicle, which is bad. And that is the light green region to the right. Oops, sorry. Yeah. When a 1 millimeter debris hits an operational spacecraft, the outcome may not be the catastrophic destruction of the vehicle, but the impact can penetrate the fuel tank, can cause problem to batteries or other critical components to terminate the mission early. That is the red zone in the middle. Mission ending is bad for the operator. At the same time, a disabled spacecraft is a sitting duck. It can potentially collide with other objects to generate more debris in the future. That is bad to the environment too. And because there's far more small millimeter-sized orbital debris than 10 centimeter and larger debris, mission ending risk is driven by millimeter-sized orbital debris. If the risk to spacecraft operating in low Earth orbit is dominated by small millimeter-sized orbital debris, then we just need to properly protect missions from such small debris. We don't want to overprotect our spacecraft. That is a cost, mass, and volume burden. We don't want to underprotect our spacecraft because that is a mission safety, a mission assurance issue. We want to protect the spacecraft just right, but we need direct measurement data on the risk driver to help us make that intelligent decision. The problem is we don't have the measurement data we need on small orbital debris to quantify the risk in a reliable way. So this is a very serious space situation awareness problem. This chart shows the measurement coverage in low Earth orbit for debris as small as 10 micrometers to 10 meters in size. DoD track objects about 10 centimeter and larger using their global space surveillance network. The recent addition of the space fence extends the range of the space surveillance network to debris about 2 centimeters. NASA uses additional radars, including Hughes and Goldstone, to characterize objects down to about 3 millimeters. Data for sub-millimeter debris comes from the inspection of hardware services returned from space. But you can see, from here, there is a critical data gap for the millimeter-sized orbital debris between 600 and 900 kilometers altitude. The reason this is a critical data gap is that, again, more than 400 spacecraft currently operate in that altitude range. Millimeter-sized orbital debris represent the highest mission-ending risk to those spacecraft, but we don't have direct measurement data on the risk driver. That is a critical space situational awareness gap. When it comes to space situational awareness, very often the focus turns to conjunction assessments with the large track objects. That is, of course, important. But from the risk management perspective, we are missing the forest for the trees. Conjunction assessment and collision avoidance maneuvers against the large track objects only account for less than 1%. Let me repeat, less than 1% of mission-ending risk from orbital debris. The mission-ending risk is driven by small millimeter-sized orbital debris. So the left side of the table outlines how we manage risk from large track debris. The first step is to observe, to collect measurement data, the tracking data. The next step is to assess the probability of collision and then make a decision to either ignore the conjunction and accept the risk, or you can conduct a collision avoidance maneuver to mitigate the risk. And there is a well-established process in place to mitigate risk from large debris, and the risk mitigation takes place during mission operations. But when we look at the right side of the table, for mitigating risk from the millimeter-sized orbital debris, there is no measurement data. Again, a critical SSA data gap. We know how to do the assessment, look into the risk from small debris. We know how to build impact shields. We just need the measurement data. Can you imagine conjunction assessments without tracking data? But that's where we are today in how we mitigate risk from small orbital debris. So space situational awareness is more than tracking the large objects in the environment. To have a complete picture and good understanding of the ever-changing orbital debris environment, NASA relies on different sensors and laboratory experiments, such as those shown at the bottom of the page. We use radars and telescopes to collect measurement data on debris down to about 3 millimeters in low Earth orbit. We examine how well surfaces return from space and use the damage on those surfaces to estimate debris smaller than 1 millimeter in size. We conduct laboratory satellite impact experiments to collect data on the physical properties of small debris, such as the shape and material density distributions, which are important for damage risk assessments. We develop in situ sensor technologies in collaboration with JAXA for future mission opportunities to address the millimeter-sized orbital debris data gap that I mentioned several times already. Of course, we also incorporate DoD tracking data on large debris into our orbital debris models and mission support tools. When there is a major breakup in space, such as the Russian anti-satellite test in November 2021, space situational awareness becomes a more urgent issue. So let me use the Russian ASAT test as an example. Right after the Russian ASAT test, the NASA Orbital Debris Program Office, we conducted risk assessments and supported development and implementation of mitigation measures to protect the International Space Station and its crew from the ASAT fragments. Based on the assessment, the critical penetration risk to the space station came from orbital debris about 2 millimeters in size, not from the large track ASAT fragments. We made special arrangements with several organizations to collect timely radar measurement data on ASAT fragments. We also reached out to the Space Force asking for the space fence data, and we were able to obtain data from the first 2 passes of the fragment cloud through the space fence. After we processed and analyzed data from different sources, we did 2 things. The first was to validate our risk assessment for the space station to identify areas for future improvements. The second was to update orbital debris engineering model, ORDEM, with a new Russian ASAT fragment component. We released the updated ORDEM model to the community in March 2022, less than 5 months after the Russian ASAT test. This chart is a composite of measurement data from different sources and our model predictions. A good example on how to utilize space situational awareness to mitigate risk to better protect operational spacecraft after a major on-orbit fragmentation event. The SSN data covers fragments down to about 10 centimeters in size. The space fence data extend the coverage in this case to about 3 centimeters. With HUSER, we detected ASAT fragments down to about 4 millimeters. With Goldstone, we were able to detect ASAT fragments as small as about 2 millimeters. As you can see from the comparison, our model prediction, the black curve, matches measurement data from different sources very well. Again, we added this ASAT fragment component to ORDEN and released the updated model to the user community in less than 5 months after the Russian ASAT test. Our ORDEN model is used by hundreds of operators, NASA, US government, commercial and international, academia, and research organizations around the world for mission support and other applications. We also released ORDEN as a cloud-based application last March to better serve the user community. So to conclude my presentation, I would like to go back to the definition of space situational awareness and space traffic management. The ultimate goal of SSA and STM is to support and enhance the safety, stability, and sustainability of operation in the space environment. If safety, stability, and sustainability are priorities for SSA and STM, orbital debris is a priority. If safety is a priority for space situational awareness and space traffic management, then addressing risk from small orbital debris has to be a priority. There is a critical need to improve space situational awareness on small orbital debris to better protect future space missions. To slow down the debris population increase for a stable and sustainable space environment, the global space community must do a better job to comply to follow the existing orbital debris mitigation guidelines and best practices. And at the same time, we need to establish long-term goals, balancing mitigation and remediation to preserve the space environment for future generations. We have a beautiful planet and a nice clean space environment around it. We created a problem. We just need to find a way to fix it. Thank you.
Thank you, Dr. J.C. Liu, for the highly inspiring plenary talk on space situational awareness and space traffic management, growing concerns on space environment. May I now request Chairman ISRO to kindly honor Dr. J.C. Liu with a memento, please. I request Ms. Rijan to assist. I request Chairman ISRO to kindly do the honors, please, sir. Thank you. Thank you, sirs. So, ladies and gentlemen, with that, we come to the end of all the serious talks, and now it's time for a small entertainment. We have a dance troupe from the Shantala Arts Academy who will be performing uh, a, a performance on the dances of India. And for that, I welcome the troupe from the Shantala Arts Academy. To give you a small introduction, India has a long and storied history of dance with a wide range of styles and traditions that have evolved over the centuries. From the elegant and graceful Bharatnatyam of the south to the energetic Bhangra of the north, each region of India has its own unique dance form that reflects the culture of its people. But what makes Indian dance truly special is its ability to tell stories and convey emotion. Whether it is a romance of the Kathak, the devotion of the Kuchipudi, or the celebration of life in the Garba, Indian dance is a powerful medium for expressing the human experience. To celebrate the vibrant and rich heritage of Indian dance, with us is the team from Shantala Arts Academy with a dance performance. The Shantala Arts Academy, the brainchild of Nati Vidwan K.R.S. Prasanna, was established in 1985. Since its inception, the Academy is doing human service to the field by conducting classical dance and music classes. The artistic director of the Academy, Kayogi Guru Pulikeshi Kasturi, is a multi-talented artist, dancer, choreographer, and organizer. Hailing from a family of literary veterans, Pulikeshi had the opportunity of learning the Bharatnatyam under the tutelage of multiple veteran gurus, Dr. Lalita Srinivasan, Dr. Srimati Narmada, and Guru Prasanna Kasturi. Under the guidance of Guru Dr. Maya Rao, he completed the diploma and degree course of choreography. We now invite Guru Pulikeshi Kasturi to take over and entertain us for the next 60 minutes.